All right, thank you so much for joining us today. So, in the previous video, we talked about homogeneous differential equation and we looked at the general solution with different methods. But in this video, we are going to look at method one and we take example. So, we saw that whenever the discriminant aspect is greater than zero, then we are going to have real and distinct root, and our general solution is going to be this. And we are saying that this is true for real and different root, right? So what we are going to do here is we are going to take examples and then we see how we can solve them. So now this is what we are coming to do. So now here we want to find the general solution because there is no initial condition given to us. So the first thing that we need to do here is we need to set y to be equal to e to the power mx. So as I said, always this is constant. So what is going to be my y prime? My y prime is equal to me mx, right? And then y prime prime will be equal to m squared emx. So always this is how we are going to do things here. Now, as soon as I get my y prime prime, and my y, then I need to do substitution. I put this inside this. So since I know that y prime is equal to this, I just do substitution here. So this is going to give us m squared e to the power mx minus 2. Y prime is m e to the power mx minus 8, and y is e to the power mx is equal to 0. So you see that the process that we went through from the previous video is the same thing. So here I'll factor m e to the power mx out. M squared minus 2m minus 8 is equal to 0. So what are we going to get from here? So here we said we need to set e to the power mx to be equal to what? Not to be equal to 0, so that we can just set the other one to 0. So what are we going to do here? We are going to set e to the power x not to be equal to 0, and then we are going to pick. So because this is the first example, I'll write the characteristics, polynomial, and everything for you. So here my p of m will be equal to m squared minus 2m minus this is the characteristic polynomial. So as we learned from the previous video, then when I set m squared minus 2m minus 8 to 0, then we call this one the characteristic equation, right? So as soon as we get the characteristics equation, then the next thing that we need to do is we need to find the characteristic root, right? We need to find the root. So here, if you don't know how to use let me say, if you don't know how to do factorization, you can use the quadratic formula to solve, right? So I would say for roots of the characteristics equation, you can skip this. This is the first time. That's the reason why I just want to write everything for us to see. So in the next example, I'll just be skipping everything here so that we can go fast. Good. Good. So now we are going to use the quadratic, right? So we know that m should be equal to minus b plus or minus b squared minus 4ac divided by 2a. Good. So now what are we going to do? We know that a is equal to 1, b is equal to minus 2, and c is equal to minus 8 from the characteristics equation. Now let's do substitution to find m. This is going to be minus 2 plus or minus square root of b is minus 2 squared minus 4 times a, which is 1, and then 8 minus 8. Good. Divided by 2 times a. So this is going to give us 4 plus or minus square root of 4 plus 4 times 8 is 32 divided by 2. So this is going to give us 4 plus or minus square root of 36 divided by 32, and this is mass 4 Square root of 36 is 6 divided by 2. Now here we can have two roots here. We can have m1, which is equal to 4 plus 6 divided by 2, which is going to be 10 divided by 2, and this is going to give us 5. Or we can have m is equal to 4 minus 6 divided by 2, and this is minus 2 divided by 2, which is minus 1. So we can see that this is kind of plus or minus. So since it's a plus or minus, that's what we just need to do. Oops. I think this one's supposed to be 2. Yeah, this one's supposed to be 2. So this one will be 2. This is going to give us 8, right? And this is supposed to be 4. Good. And then this is going to be 2. So this is going to give us 4. And this is going to give us minus 2. Good. So now you've gotten m1 and m2. That is the most important thing. These are the roots of the characteristics equation. So now everything is very simple. What we just need to do is we just need to write out the general solution, and then we are done. So let me try and do it for you. So the general solution is going to give us y is equal to, we know that it's c1 e to the power m1x plus c2 e to the power m2x. Always try and write this one before, so that you always be writing the formula so that you remember it. So this is going to give us c1 e to the power m1 is 4x plus m2 is minus 2x. Now somebody is asking, what if I chose this one to be m2 and this one to be m1? It's the same thing. So if we change this one to be, let me say, if we assume that m1 was equal to 2 minus 6, you're going to get m1 to be this, and then your m2 is going to be this. So your solution is just going to be c1 e to the power minus 2x plus c2 e to the power 4x, and this is also correct. So this is the general solution. Since we don't have initial value initial condition, we cannot find particular solution. So now let's look at another question which has initial condition, right? So the same process, as I said, we have y prime prime plus y prime to be equal to 0. So same procedure, find your y prime. So you see that when you do it, like when you solve 1, 2, 3 examples, you will know that now y will be equal to e to the power mx, y prime will be equal to this, and then y prime prime will be equal to m squared. It's the same process. When I do it and I do substitution, y prime prime, y prime, here we don't have y, so I'm going to have m squared e to the power mx plus me mx, which is equal to 0. So this is what I'm going to get. Now what can I do again? The same process again. Factor e to the power mx out. M squared plus this is equal to 0. And we are saying that this shouldn't be equal to 0. M squared plus m is equal to 0. So what are we going to get from here? So if this one is equal to 0, then here I can factor m out and have m plus 1 is equal to 0. And then I'm going to have m is equal to 0, and then m plus 1 is equal to 0, and m is equal to minus 1, right? So I can say that my m1 is 0 and my m2 is equal to minus 1. You can choose m1 to be minus 1 and m2 to be 0. It's the same thing, right? Good. So as I said, this becomes the characteristics equation, and this becomes the characteristics root. And then when I set this one to be p of m, this becomes the characteristics polynomial, sake of maybe objectives, and then if the question is asking for those kind of things, that's the reason why I keep mentioning them. So now that I have this one, I can write the general solution. So since this one we have initial condition, let me write this one, general solution. So general solution is going to give us y is equal to, I'll write the formula again so that we remember what we are just doing. So e to the power m2x. So what is m1 is 0, so I'm going to have c e to the power 0 times x will be 0 plus c2 is equal to minus x, and this is going to give us c1 plus c2 e to the power minus x. So this is the general solution. Here we have initial condition, so this will help us to find the particular solution. So let's see how we can use this one since we have two of them. So the first initial condition is, let me just divide this one into two here. Y of 0 is equal to 1. Now this implies that y is equal to 1 and x is equal to 0. And then y prime of 0 is equal to minus half. So y prime of 0 is equal to minus half. Is that right? Good. So this implies that y prime is equal to minus 1 over 2 and x is also equal to 0. So this is what we are going to do. Since we have this one here, we can use the first initial condition to solve this. So let's do that. Using y of 0 to be equal to 1, we are going to have y is 1, which is equal to c1 plus c2 e to the power x is 0. So that's what we are going to have. So we are going to have x is 0. So 1 is equal to c1 plus c2. E to the power 0 is 1. So I'm going to have this one. Let me say equation 1. C1 is equal to 1 minus C2. Let me call this one equation 1. Then I'm going to use the second initial condition, which says that y prime of 0 is equal to minus 1 over 2. So you see that this is going with y prime. So what I need to do is I need to differentiate my general solution. So now let's differentiate this function here and see what we are going to get. Y prime is equal to, when I differentiate a constant, I get 0. When I differentiate this, e to the power minus x, I'm going to have minus e to the power minus x. Then I multiply by c2. So this is going to give us minus c2 e to the power this. So this is what we have. Now we know that y prime is equal to minus half, and then x is equal to 0. So we are going to have this one to be minus 1 over 2, which is equal to minus c2 e to the power 0. So this is going to give us minus 1 over 2, which is equal to minus c2. So c2 will be equal to 1 over 2. So now that we know c2, we can put it inside c1 and find for, equation 1 and find for c1. So now c1 will be equal to 1 minus half, and this is also going to give us half. So the particular solution is going to be y is equal to c1 is half. So we are writing the particular solution from here, the general solution. So we are going to have 1 over 2 plus 1 over 2 e to the power minus x. So as we said, particular solution is when we find a constant in the general solutions. So this becomes the particular solution. So they are very, very simple. The same steps over and over again. It's just the function which changes. Let's take another one and see how it's going to be. Now, same thing again. I have y prime prime minus 4y prime, which is equal to 0, right? So the same thing, y is equal to e to the power this, y prime prime, y prime is equal to this, and then y prime prime will be m squared e this. So it's the same thing. So let's do substitution here. We are going to have m squared e to the power mx plus minus 4m e to the power mx is equal to 0. So the same thing, you see that we need to factor this guy out, left with m squared minus 4, which is equal to 0, right? And then we are going to say that this guy is never 0, and then it means that our m squared minus 4 should be equal to 0. So m squared is equal to 4. Take the square root on both sides, and this is going to give us plus or minus 2. So we can say that m1 is equal to 2 and then m2 is equal to minus 2. So what will be the general solution? The general solution C1 m1x plus C2 m2x, and this is going to give us C1 e to the power 2x plus C2 e to the power minus 2x. So this will be the general solution, right? So if this is the general solution, we have initial condition. So since we have y prime here, let's differentiate the function. When I differentiate this, I'm going to have, when I differentiate this, I'm going to have 2e to the power 2x, right? Because I need to just differentiate the top and multiply by the function. So this is going to give us 2c1 e to the power 2x. Same thing here, differentiate the top and use to multiply the whole function. So this is going to be minus 2c2 e to the power minus 2x. Now let's use the initial conditions. So the first initial condition is y of 0 is equal to 3. So x is equal to 0 and y is equal to 3. So the one that involves, so don't forget, this is the general solution. So the one that involves y and x is this one. This is y prime and x. So let's use this one. Y is equal to 3. So I'm going to have 3 is equal to c1 e to the power 0 plus c2 e to the power 0. So plug in 0 here, 0 here. So this will be 3 is equal to c1 plus c2. So c1 is the same as 3 minus c2. Let's say equation 1. Let's use the other initial condition. Y prime of 0 is 10. So x is equal to 0, y prime is equal to 10. So the one that involves y prime and x is the one that we took the first derivative. So this is going to be 10 is equal to 2c1 e to the power 0 minus 2c1 c2 e to the power 0. So this is 10 is equal to 2c1 minus 2c2. Let's divide through by 2 and we are going to have 5 is equal to let me say c1 minus c2. Let's make c1 the subject. c1 will be equal to 5 plus c2. Let me call this one to equation 2. So equation 1 is c is equal to c1 is equal to this. Equation 2 to c1 is equal to this. It means that this is the same as that. So I'm going to have 3 minus c2 to be equal to 5 plus c2. And then let's move them. Move 5 to the let me say the left and c2 to the right. We are going to have 3 minus 5 is equal to c2 plus c2. So this is minus 2 is equal to 2c2 and c2 should be equal to minus 1. So now that we know c2 to be minus 1, we can plug it inside equation 1 to find c1 or equation 2 to find c1. So any of them. So from equation 1, we are going to have 3 minus 1, which is going to be 3 plus 1, and c1 will be 4. When you plug it in here too, you are going to get 4. So it means that now the particular solution, we are going to have y, which is going to be 4 e to the power 2x minus e to the power minus 2x. So this is the particular solution from the general solution. So it's very, very simple. So if you look at it, you see that anytime we start, something is repeating itself. So that is basically homogeneous second order differential equation. You will see that you are going to have this term, and then the next step is just do substitution. The next step, you are going to factor this guy out. The next step, you are going to say that this guy is not equal to 0. The next step, you pick this one, you set it to 0. If it is not very simple for you to simplify, you use a quadratic formula to solve. Get your m1, m2. If they are distinct, you write down your general solution like this, and then you plug in M1 and M2, and then you are done. So I have a question that is here that I want to give it to you for you to also try. Please, I appreciate you guys. I think you guys are doing very well. You will leave your final results in the comment section, which is kind of a way of replying to your comment, right? Kind of building that community from there. So try this one and put your answer in the comment section. So in the next video, we are going to talk about when b squared minus 4ac is equal to 0. That's the second method in the next video. So see you in the next video.